war. Einstein lived in Germany at the time, but his work landed in the hands of a British astrophysicist, Arthur Eddington. Even though they were on opposing sides of the war, Eddington, along with astronomer Frank Dyson, set out to test the theory. They would photograph a total solar eclipse. They needed to compare the position of a cluster of stars in the night sky with a photograph of the same stars during an eclipse. If the stars' apparent positions had shifted, it would prove that starlight was traveling through space curved by the sun's gravity. The May 1919 eclipse was the ideal one for this experiment. The sun would be in front of a very dense cluster of stars, the Hyades, and that meant multiple bright stars would be visible during the eclipse. Planning began in 1917, and a couple of years later, 2 expeditions departed England. One, led by Eddington, went to the island of Principe in West Africa, and the other headed to Sobral, Brazil. 2 locations that were in the path of the eclipse and had favorable climates. Each group traveled with powerful photographic telescopes that could record detailed photos of space onto glass plates. Photographing the eclipse that May required transporting and then carefully assembling them in the field, with the plates tilted 45 degrees on one of the telescopes to include as many bright stars as possible. And this was the result. This is one of the few successful plates from the 1919 expeditions. It came from Brazil. It shows the eclipse during totality, the sun's corona bursting forth, and the rarely seen solar prominence. Most importantly, bright stars of the Hyades. Back in England, Eddington compared the position of the stars from the eclipse plate with another of the night sky, using a machine that can take measurements within photos at the microscopic level. The comparison revealed that the stars had